Hey y'all, welcome back. So today we are working on our review of rational numbers. Specifically, we have been looking at fractions, decimals, and we spent a little extra time talking about percents as well, and answering questions that you might expect to see on the TSI exam that have to do with these kind of numbers. So let's get into the review. First one says, what is 314% of 13? And anytime you get a percent question, I like to just translate it word by word. So what is x equals 314% is 3.14 of, is always talking about multiplication when it comes to percents, of 13. And from here, I'm going to use my calculator. So over the side, I'm going to turn this on. I'm just going to type in 3.14 times 13. And that gives me my answer here. So I would say that 40.82 is 314% of 13. Number 2 says, what is 1/4 divided by 2/5? Just like with number 1, anytime you've got just some basic arithmetic you got to do, just go ahead and use the calculator to compute that. So here I've got 1/4, which I'll need to put it in as a fraction, and the calculator you're dealing with is the XS, and it has that dedicated fraction button. So make sure you are aware of that. 1/4 divided by 2/5. This 84 does not have the dedicated fraction button, so it takes me a couple extra button presses to get it in there. But still should get the same answer here, which is 5/8. Number 3, 100 minus 22 and 3/5. So don't forget that when you have a mixed number like this, like 22 and 3/5, that's actually going to be 22 plus 3/5 when you go to type that in. So 100 minus 22 plus 3/5. And I get 393/5. Now you might have this number as a decimal, and that's okay too. If I want to know what it is as a decimal, I wonder if I can just go ahead and divide this out. If not, we might just have to convert it. Oh, yep, there we go. So this, you could also write this as 78.6. And I'll accept either one. Just be ready to go back and forth. You've got the button right above your enter button. Not on this calculator I'm using, but the one you're going to use in class, that will convert back and forth between fractions and decimals. You're going to find it like, if you can see where my cursor, I don't know if you can actually see this. Oh yeah, so there's my cursor. On your calculator, you've got the enter button in the bottom right hand corner like I do, and then right above it, you've got like a 2 arrow. You don't see it on this one, but on the calculator you're using, you've got 2 arrows here that can go back and forth between fraction and decimals. So make sure you know how to use that too. Number 4 says, what is the approximate percent decrease when the deer population goes down from 750 to 400? So when we're trying to calculate a percent change, and maybe I'll just go ahead and write that out here, the percent change is going to be equal to, and then it's going to be a fraction, the actual change, so whatever the change happens to be, increase or decrease, plus or minus, divided by the original amount. So this is going to be how we calculate the percent change, whether it's a percent increase or a percent decrease. And we'll just want to make sure that we declare that it's an increase or a decrease when we answer a question. So this one's going down from 750 to 400, so we know it's going to be a decrease, but let's calculate what it actually is. So the change is going to be 750 minus 400 over the original amount, which is 750. So this is something that I will just put into my calculator over here. Set up a little fraction, 750 minus 400, that's the change. That's how much the deer population is changing by, divided by the original deer population, 750. is going to be 7/15. So as a decimal, which is kind of how I want this, I'm going to go ahead and convert mine. Not to a fraction. We want to convert it to a decimal. So it's about 0.4, we'll just call it 7. We'll round up to 7. So about 47%. Now you also want to say whether or not it's an increase or decrease, and we already established that since it's going down, this is going to be a decrease. So it's about a 47% decrease. Number 5 is kind of a similar question here. It says, a sports team held a fundraiser last year and raised $400 to help team expenses. This year, they raised $530. What is the percent change in the total amount raised by the team? So first, we'll figure out what the change is, the actual change in dollar amount, and then divide that by the original amount to find the percent change. So we've got 530 minus 400. It's going to give us the change in from last year to this year, over 400, which was the original amount. Now let's go ahead and divide here. Got 530 minus 400 over 400. Oh, not 4,000. There we go. It's going to give me this fraction. That's the rational number, but I'm going to convert that to a decimal. So I get 32.5%. I guess maybe I should write that here. So the original, like the actual decimal amount is 325 thousandths, which is 32.5%. Remember that a percent is just a number out of 100. So if you're ever not sure, what the percent means, like 32.5% really just means 32.5 out of 100. And so if you do this little division, you should get the same number as we got initially, which is 0.325. So now we want to think about whether or not this is an increase or decrease. And since last year they only raised $400 and this year $530, this is going to be an increase. Number 6 says the owner of a gym decides to increase the $45 membership fee by $12. What's the approximate percent increase in the fee? So this time they're actually giving you the change and the original amount. You don't have to calculate the change like we did in the last two problems. So this is just simply going to be 12 over 45. And we can go ahead and divide that. 12 divided by 45 is about 0.267 or 0.27. Go ahead and say approximately here. That's what this little squiggly equals means. And use that when it's not exactly. So we're going to say approximately 27%. And I guess we should say increase here, even though it tells us it's an increase. We want to make sure we're answering the question that's being asked. What is the approximate percent increase? And so we're going to say it's a 27% increase. Number 7 says the airline has a limit of 50 pounds per luggage one can bring on the plane. Your luggage weighs 82% of the 50-pound capacity. How many pounds does your luggage weigh? So really what this is asking is, what is 82% of 50 pounds? So when we rephrase it like that, you can see it's going to be the same kind of question that we had with number 1, where all we need to do is just multiply the percent by the amount. So what is, that's like x equals 82% of means to multiply. So x is 82% of 50. Go ahead and type that in. 82%, 0.82 times 50 is 41. So 41 is 82% of 50. All right, so let's make sure we're actually answering the question here. It says, how many pounds does your luggage weigh? So I would say something like, my luggage weighs 41 pounds. Number 8 says, Luke has driven 43% of an hour-long drive. How many minutes has he driven? So we're going to try to translate this into just a direct percent question. What is 43% of an hour? So we're going to call that 60 minutes. So the question is asking for how many minutes, and an hour is 60 minutes. So what is 43% of 60 minutes? So x is 43%, so that's going to be 0.43 of 60. And so let's type that in. Once again, here we got 0.43 times 60, and we get 25.8. So 25.8 is 43% of 60. So how many minutes has he driven? Well, he's driven exactly that many minutes. So Luke has driven 25.8 minutes. Number 9 says Jesse wants to give a 20% gratuity to his Uber driver. Her fare is $24.75. What is the total amount she will pay the driver? So we want to know what is 20%. So first, we want to answer the question, what is 20% of $24.75? And that's going to figure out her tip. And that's really all gratuity means. Okay, if you ever see the word gratuity, it just means tip. So that's the first question we want to answer. And then the second question we actually want to answer is how much is she actually going to pay? So we're going to add that back to the original amount. So add the tip back to the original amount. All right, so let's first answer the first question. What is 20% of $24.75? So if the tip is going to be 20%, that's 0.2 of is multiply 24.75. Let's see what that's going to equal. 0.2 times 24.75 is 4.95. So that's how much the tip is going to be, is or the gratuity is $4.95. So what we need to do to get the total amount is to add back that tip to the original amount. So $4.95 plus the $24.75, and that's going to give us our final answer. So $4.95 plus $24.75 is $29.70. Number 10 says Jim and his friends went out to lunch, and the bill came out to $98. Together, they decided to also tip a total of 18% of the bill. And finally, they decided to split the total bill, including the tip, amongst all 6 friends. How much did Jim spend? Okay, so first, we need to figure out, we've got the total amount, right? So we have the total amount, we need to figure out the tip. So what is the tip? What is 18% of 98? Okay, that's going to tell us how much the group is going to tip. Then, like the last problem, we need to add the tip back to the original amount. And then finally, since we're splitting up the bill amongst 6 friends, Jim and his other, I guess, 5 other friends, we're going to divide the new total by 6. And this is going to be our process here. I just wanted to kind of write out our strategy here for answering this question, and that way we can take it step by step. So first, we're going to find the tip. So that tip is going to be 18% or 0.18 of 98. So 0.18 times 98 18% of 98 is 1764. And then we want to find the total. It's going to be our next step here. Well, I'll just type it down here, I guess. Our total is going to be the original $98 plus the tip, which is $17.67. And that, let's see what that'll be. $98 plus $17.67 is $115.67. So $115.67 is going to be the total amount that the group pays. And if we're going to try to divide this by 6, I don't know if that's actually going to divide evenly here. Okay, someone's going to pick up an extra penny. But I guess we could say each, let's see, Jim spent $19. And we can either say 27 or 28, depending on whether or not Jim wants to be nice. We'll just say about, or approximately is probably a better word to use here. And I'm going to go ahead and round up because it is 27.8. And just assume that Jim's going to be one of the people that spends an extra penny. Now, if you put 1927, that's fine too. Number 11. Brianna's mom takes her and her 2 other friends to the movies. She bought 3 large popcorns, each of which cost $4.50. She also bought 4 fountain drinks for $3 each. The movie tickets cost $15 each. And I guess she bought 4, obviously, because there's 3 people. Finally, Brianna used a 20% off coupon for the total order. How much did she spend? Okay, so let's first figure out the total. Okay, so find the total. And then we're going to find what is 20% of the total. And then our last step is going to be to subtract that 20% from the total. And that's going to give us the amount that she spent. So first, let's find the total. So she bought 3 large popcorns, each which cost $4.50. So that's 3 times, I'll put it right like this, $4.50, plus 4 fountain drinks for $3 each. And then 4 movie tickets for $15 each. We're going to calculate this out. 3 times $4.50 plus 4 times 3, which I guess I could just say is 12, but I'll just kind of type this in exactly how it looks. Plus 4 times 15 is $85.50. 20% of that total is going to be, what is 20%? So that's 0.2, 20% of the $85.50. So that's going to be $17.10. And then, so that's how much we're going to get discounted. That's 20% off the original amount. So to actually find the total amount here, we're going to subtract that 1710 from the 1850 or 8550. This is going to give us the amount that Brianna's mom actually spent, which is $68.40. Number 12 says express the shaded region as a fraction, percent, and decimal. So when you're trying to model a fraction with a diagram, like a picture like this, usually we use shaded regions to do so. And so to write this as a fraction, we're going to write down the number of shaded regions divided by the total number of regions. All right, so we can just count these. We've got 3 shaded regions out of a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is that right? Wait, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, so 3 out of 10. So we've expressed it as a fraction, and now we want to express it as a percent and a decimal. I kind of wish I wrote these in the other order because we're finding it as a decimal is what you're going to want to do first. So 3 divided by 10, this is something you could do in your calculator if you're not sure, but it's going to be 3/10. Seems kind of obvious once you say it out loud. Yeah, so 0.3, which is going to be 30%. 30%. So we got a fraction, a decimal, and a percent. Number 13 says reduce the fraction 5 over 40. And your calculator should be able to do this for you. If not, if you're not sure how to do it in your calculator, typically you just write the fraction and hit enter. Like if I just type in 5 over 40 and hit enter, it should reduce for me. But if you're trying to do it by hand, which you don't need to do, but if you wanted to kind of know how it's computing this new fraction, you just find the largest common divisor, or that divides both 5 and 40, and that number would be 5. Both 5 and 40 are divisible by 5, and so you'd get 1/8. The next one says convert 3/5 to a percent, and to get there, we're going to convert to a decimal first. So I'm going to say that 3/5 is equal to, and then I'm just going to divide this. 3/5 is 0.6, and 0.6 as a percent is 60%. Number 15, Holden wants to tip the waitstaff 20% of the bill for good service. If Holden's bill is $28, how much tip should he leave for the waitstaff? So first we're going to figure out what is 20% of $28, and then we're going to add that back to the original bill. So add the tip to the original bill. Okay, so 20% of 28 is just going to be 0.2 times 28. I'm getting 5.6. So that's going to be $5.60 is going to be the tip. And then I want to add that back to the original amount, which was 28. So 28 plus 560. It's going to be $33.60. So this is going to be the total amount. Now the question was actually, now I'm rereading this, is how much tip should he leave the waitstaff? So we want to make sure that we're actually answering that question. And so we didn't really need to go back and add it back. We did not need to do this. It's not that this is wrong or anything, but it's just not what the question's asking for. So we could have stopped up here and just said, oh, he wants to leave $5.60 for the waitstaff. Number 16 says Siri wants to buy a $41 shirt. At the register, she's charged 8.25% in sales tax, which is what we have in Austin, Texas. How much does Siri have to pay for the shirt, including tax? Okay, so this one we are going to need to go back and add that percent increase, the amount that we're adding for tax back to the original amount. So it's going to be kind of like what we did up here, but without crossing out the second step. So first, we want to know like how much tax is being charged. So we want to know what is 8.25% of 41. So we're going to find the tax. We got 0. Now this one's a little tricky because it's a decimal and it's only less than 10 decimals. So 0.0825 is 8.25% as a decimal times 41. So 0.0825 times 41. Okay, so we've got 3.38. Okay, we're going to round down here. When we talk about money or dollar amounts, we do not go past the hundreds. So this is going to be our tax. So what we need to do after we calculate our tax is add that back to the original amount. So add the tax to the original bill. And so we've got the original bill, which is $41 for the shirt, plus the $3.38, which is the tax, and that's going to give me $44.38. Number 17 says 26 out of 30 students passed the last history test. Approximately what percent of the students passed the test? So what we need to do is we need to convert 26 out of 30 to a percent. And so first we'll convert it to a decimal. 26 divided by 30 is going to be, I'll actually say instead of equals, since we have this repeating decimal, approximately equal to 0.87 or even 867. I don't really care if you go 2 or 3 decimals out. Actually, I think I did 2 decimals before, so maybe I should stay consistent here and just do 0.87. So we're going to say about or approximately 87% of the students passed the history test.
It says convert 24% to a reduced fraction. So first, we're going to consider this percent as a decimal. 24% is the same thing as 24 over 100. And while your calculator can go ahead and do this, if you just type in 24 over 100, it will reduce it for you. But really what you want to do, if you're going to try to do this without a calculator, is to find the greatest common factor of both 24 and 100. Now for these two numbers, the greatest common factor is 4. So I'll divide both the top and the bottom by 4 to give me 6 over 25. Now again, if you're using a calculator like the TI-30XSs that we're using in class, you could just type in 24 out of 100 and hit enter, and it'll give you that reduced fraction. Number 19 says a certain map has a scale in which 1/4 inch on the map represents an actual distance of 100 feet. A distance of x feet is represented by how many inches on this map. Now, I used to teach this problem a little differently, which is I used to have you come up with this expression by setting up an equation and solving it. But the more I've worked through this with different students, what I've found to be the most effective way to actually answer this question is just to take advantage of the fact that it is multiple choice. We know that 100 real feet is the same thing as 1/4 inch on the map. And if we're letting x be the real number of feet, so this is like our x over here, we want to know how many inches are on the map, and all these expressions are in terms of x. So anyway, I think the easiest way to work this problem out, you could do it algebraically. I think it's kind of confusing if you do it that way. Um, is just to test each answer choice and plug in 100 into x and find out which one gives you 1/4. So we'll start with A. We'll plug in 100 into x, and actually right away we do get 1/4. Looks like our answer is A, but let's just check the other ones just to make sure. 100 out of 100, that's just 1, so that's not right. 25 times 100, well, you could see right away that's going to be way too big. It's going to be 2,500. We're looking for 1/4 of an inch. And for choice D, 400 times 100, yeah, again, obviously this is not going to be right. That's 40,000. The only answer choice that comes close and is even the answer is choice A. So again, just test this number into each answer choice. You should get it pretty easily. And we can skip the algebra on this one. Number 20 says the bar graph shows the number of customers who shopped at a store Monday through Thursday of 1 week. If the number of customers on Friday was a 40% increase from the number of customers on Thursday, how many customers shop at the store on Friday? So on Thursday, we can see that there were 400 customers. If there was a 40% increase from Thursday to Friday, then if Thursday is 100%, which is 400 customers, and Friday is a 40% increase, then we're going to have 140% of what we had on Thursday. So what we need is 140% of 400. So 140% as a decimal is 1.40, and then times 400. This is something you'll just type into the calculator. 1.4 times 400 is 560. So there's 560 customers on Friday. Number 21 says during a sale, the regular price of a smartphone is reduced by 20%. If the sale price is $640, what is the regular price of the smartphone? Okay, so we're looking for a smartphone to be reduced by 20% and the sale price is $640. So some number times, so we'll say this is the original price, okay, and we'll call it X. That's what we're looking for. And we want to be careful here because it's reduced by 20%. So we're really going to be multiplying this by 80% to get the sale price, which is $640. So now to kind of work backwards to get that X, to get that original price, we're going to divide both sides by 80%. And that should pretty much give us our answer here. 640 divided by 0.8 is 800. You can also just check this, this will be multiple choice on the test. So you could just check all the answer choices and find out which one's 80% of 800, or sorry, which one, 80% of which answer choice is 640. And you should be able to get it that way also. Number 22 says a pair of headphones is on sale for 35% off the original price of X dollars. A customer has a coupon for $10 off the sale price. Which of the following represents the price in dollars the customer will pay excluding tax for the headphones? So we really just want to kind of follow the money here. You're buying a pair of headphones, and initially it's 30% off the original price. So if it's 30% off, that means you pay the remainder, which is 65%, okay, of the original cost. And we're going to call X the original cost. Okay, then it says you take $10 off. So if you take $10 off the sale price, which is what we have, what we're going to have initially, that just means we're going to subtract 10. Okay, so let's break this down. We want 65% of the original cost. That's going to be 0.65 times X, and then $10 off of that means we subtract 10. I think the most commonly chosen answer here that is incorrect would be C. don't be fooled on this one. If choice C would have to say something like the $10 that you're taking off comes first before you apply the discount. But no, this problem's pretty clear. It says that the customer has a coupon for $10 off the sale price, not off of the original price. So you do have to do that 65% first and then subtract the 10. So it's really just like an order of operations question here. We want to make sure we apply the discount and then take the $10 off at the end. So yeah, be careful with that distractor item. Number 23 says the dot plot identifies the number of students present in each of 20 rooms. So you have 20 rooms and each room has so many students. Just to try to understand this little dot plot, what this means is there are 4 rooms with 0 students. Okay, this over here, or that might be not the best example here. Here there's 1, 2, 3, 4, 5 rooms with students. Okay, so now that we understand the dot plot, we can answer this question. What fraction of rooms have more than 1 student? So right here, this is 1 student. We want the rooms with more than 1 student, so that's going to be all of these. So basically, we just have to count up the number of rooms, and it told us the number is 20, so we don't have to actually count them all up. We just need to count up the number that have more than 1 student. So let's see, we've got 1, 2, 3, 4, 5, and 2 with 2 students. Did I say 4 students here? Oh, my bad. I meant 2 students. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, and then 9. So we have a total of 9 rooms with more than 1 student, and there's a total of 20 rooms. So 9 out of 20 have more than 1 student. Number 24 says Craig's weekly salary is $435 plus 8% of his weekly sales. Write an equation that expresses the relationship between his salary and his weekly sales. So his salary, and I'm just going to follow along with the sentence. His weekly salary is, so salary is $435 plus 8% of his weekly sales. Now we want to be careful. We can't write a percent in an equation. We've got to write it either as a decimal or a fraction. I'll go with a fraction, but you could write it as a decimal as well. 8% is 0.08 of the weekly sales, so times W. Of being multiply, 8% being the 0.08, and the weekly sales is W. And our last question says the tuition for 1 year at college is $3,700. If the tuition increases by 25%, what will be the new cost of tuition? So what we need is actually 125% of 3,700. Because of the 3,700, that's like our 100%, but we need to add on the extra 25% of that. So here we're just going to do 1.25 times 3,700. 1.25 times 3,700 is 4,625. And boys, college getting expensive. Oof. Yep. All right. Well, that about wraps it up for tonight's review. If you have any questions on any of these problems, please reach out and I'll be happy to help you. The test will be multiple choice. I know most of these questions on the review were not multiple choice, but really it's just I want to force you to know how to work these problems out. But when you do get in there and take the test, please know that you can kind of work backwards on a lot of these problems. If there's a problem you just don't know how to do, try to see if you can sort of reverse engineer it and take advantage of the fact that it's multiple choice and see if you can't work it backwards that way. Kind of how we did in class. So anyway, good luck on your test. I'll see you next time.